Hello, this part one of a two-part series is all about periodic law. This is what's known as the father of the periodic table, Dmitri Mendeleev. You would hear about him all the time in Honors Chem or AP. But for here, just a simple little pick of what he did. Now, the first trend that we're going to talk about is the atomic radii. Now, trends are not 100%. They're tendency for occurrences. They're just likely to occur. So atomic radii is the size of the atom, as modeled here by this little representation. So the period trend, which is across, decreases across. Now the y is a little different. It has the same energy level across the period, but more protons means that the pull of the outer valence electrons closer, making the atom smaller. Going down, the group trend increases. This increases because, here's the y, with each element down, there's one more energy level, increasing the size of the atom. So you might remember this being in period 1 has 1 energy level, period 2, 2 energy levels, period 3, 3 energy levels, and so on. That is the y for the group trend. Let's look at it for ionization energies, because size matters. So this is the energy required to remove an electron from a neutral atom. The across trend, so the period trend, is it increases across the period. Y is across the atom becomes smaller, so the electron that is removed is closer, requiring more energy to remove it. These are the values of the amount of energy in kilojoules to remove. So again, across the atom becomes smaller, so the electron that is removed is closer, requiring more energy to remove it. Going down, the group trend is it decreases. Going down a group, you might remember the atoms get larger, so the outer valence electrons are further from the protons, meaning less energy needed to remove that electron, less of an attraction, so therefore less energy. You might see some discrepancies here and there, but remember these are trends, not everything set in stone. So that's if you remove one electron. After one, now what happens? Well, each additional electron to be removed after the first requires more energy than it did before. Here's some values. So the first ionization energy, 496. The second, much higher. The first one, second one, a third one, first, second, third, fourth. You might notice quite a big jump when it goes to an inner energy level. And that's because after one electron is removed, the remainder are closer to the nucleus, so more energy is required. So the y, there are less electrons pushing apart in the outer energy level, so the remaining electrons move closer, increasing the attraction and therefore increasing the ionization energy needed. We're going to transition now to part 2. See you there.